The butterfly-shaped coronal hole, a window into the sun's dynamic atmosphere and its earthly repercussions. In the vast expanse of our solar system, the sun stands as a colossal nuclear furnace, not only providing the light and heat essential for life on Earth, but also exhibiting a dynamic and often unpredictable behavior that can influence our planet in profound ways. On September 11, 2025, NASA's Solar Dynamics Observatory, SDO, captured imagery of a remarkable feature on the sun's surface. A massive, butterfly-shaped coronal hole spanning approximately 500,000 kilometers, about 310,000 miles, across, roughly 40 times the diameter of Earth. This dark winged patch in the sun's corona, the outermost layer of its atmosphere, quickly became a topic of fascination among astronomers, space weather enthusiasts, and the public alike. Far from being a literal hole or a sign of solar decay, this coronal hole represents an opening in the sun's magnetic field, allowing high-speed solar wind to escape into space and potentially interact with Earth's magnetosphere. This event, dubbed the Big Butterfly by space weather experts, is not an isolated anomaly, but part of the sun's ongoing activity during solar cycle 25, which is approaching its peak. Coronal holes are common solar phenomena, but the distinctive butterfly shape of this one, resembling outstretched wings, has sparked widespread interest, amplified by social media shares and viral time-lapse videos. In this essay, we will delve deeply into the science behind coronal holes, explore the specifics of this September 2025 occurrence, examine its potential impacts on Earth, and contextualize it within broader astronomical and historical frameworks. Through examples from past events, detailed explanations of solar physics, and insights from ongoing observations, we aim to illuminate how such solar features bridge the gap between celestial wonders and terrestrial realities. Understanding coronal holes, the science behind the phenomenon. To appreciate the significance of the butterfly-shaped coronal hole, it is essential first to understand what coronal holes are and how they form. The sun's corona is a tenuous, superheated plasma extending millions of kilometers into space, with temperatures soaring above 1 million degrees Celsius, paradoxically hotter than the sun's surface, which hovers around 5,500 degrees. This corona is structured by the sun's magnetic field, generated by the churning plasma in its interior through a process known as the solar dynamo. Coronal holes occur where the sun's magnetic field lines are open, meaning they extend outward into interplanetary space rather than looping back to the solar surface. In these regions, the plasma density is lower, and the temperature is relatively cooler, though still extremely hot by earthly standards, causing them to appear dark in extreme ultraviolet, EUV, and X-ray images. This darkness arises because there is less hot, glowing material to emit light in those wavelengths. The escaping plasma forms the solar wind, a stream of charged particles, protons, electrons, and alpha particles, traveling at speeds of 300 to 800 kilometers per second. The shape of coronal holes is dictated by the complex topology of the solar magnetic field, which can twist and contort due to differential rotation. The sun's equator rotates faster than its poles. This can lead to irregular, asymmetrical forms, including the butterfly-like configuration observed in September 2025. Notably, this should not be confused with the butterfly diagram in solar physics, a historical graph developed by Edward Maunder in the early 20th century. The diagram plots sunspot latitudes over time during solar cycles, revealing a pattern that resembles butterfly wings as sunspots migrate from mid-latitudes toward the equator. While both involve butterflies, the diagram is a tool for tracking solar activity cycles, whereas the coronal hole is aerial time atmospheric feature. Coronal holes are more prevalent during the declining phase and minimum of the 11-year solar cycle, but can appear at any time. During solar cycle 25, which began in December 2019 and is projected to peak around 2025-2026, increased magnetic activity has led to more frequent and larger holes. For instance, A massive coronal hole in March 2023, dubbed the smiley face due to its shape, unleashed solar winds that triggered one of the strongest geomagnetic storms in years, rated G4, severe, leading to auroras visible as far south as Arizona in the United States. The September 2025 butterfly-shaped coronal hole, observations and details. The butterfly-shaped coronal hole was first prominently observed on September 11, 2025, in the Sun's southern hemisphere, as captured by NASA's SDO in EUV wavelengths, specifically at 193 angstroms, which highlights plasma at about 1.2 million Kelvin. Time-lapse footage from SDO shows the hole evolving over September 11 to 12, with its dark, winged silhouette, contrasting sharply against the brighter corona. The hole's size, 500,000 kilometers across, makes it one of the larger ones recorded recently, capable of engulfing dozens of Earths. Social media platforms, particularly X, formerly Twitter, buzzed with shares of these images. For example, the Starwalk app posted a video on September 12th, describing the hole as a dark patch where solar wind escapes into space, noting its Earth-facing position and potential for geomagnetic activity. Other users, like @Tex369X, referred to it as the Big Butterfly and linked it to incoming geomagnetic storms, combining it with a faint coronal mass ejection, CME, for a 1-2 punch. Enthusiasts shared animated rotations, emphasizing the hole's symmetry and how it rotated into a geo-effective position, directly facing Earth, by September 13th. This positioning is crucial because it directs the high-speed solar wind stream toward our planet. Forecasts from NOAA's Space Weather Prediction Center and the UK Met Office predicted the wind's arrival around September 13th to 14th, 2025, with speeds potentially reaching 600-800 km/s. The timing coincides with the approach of the autumnal equinox on September 22nd, enhancing effects via the Russell-McPherron effect, where Earth's magnetic field aligns more favorably with the interplanetary magnetic field, IMF, carried by the solar wind, allowing for stronger coupling and more intense geomagnetic disturbances. Impacts on Earth, from auroras to technological disruptions. The primary consequence of coronal holes is the emission of high-speed solar wind streams, HSS, which, upon reaching Earth, compress the magnetosphere and inject energy into it, leading to geomagnetic storms. These storms are classified on a G scale from G1, minor, to G5, extreme. For the September 2025 event, predictions ranged from G1 to G2 levels, meaning minor to moderate impacts. One of the most visually spectacular effects is the enhancement of auroras, the northern and southern lights. When solar wind particles collide with Earth's atmospheric gases, oxygen and nitrogen, they excite the atoms, which then emit light in greens, reds, and purples. During G2 storms, auroras can be visible at latitudes as low as 50-55 degrees, potentially reaching northern US states, Canada, Scandinavia, and even parts of the UK and New Zealand. Historical examples abound. In October 2021, a coronal hole-triggered storm produced auroras visible in New York City, an unusually southern display. Beyond beauty, these storms pose risks to technology. High-frequency radio communications can be disrupted due to ionospheric scintillations. GPS signals may degrade, affecting navigation for aircraft and ships. And satellites could experience increased drag or electronic glitches. In extreme cases, like the 1989 Quebec blackout from a G5 storm, though caused by a CME, not a hole, power grids can fail. For this event, however, disruptions were expected to be minor, with no widespread blackouts forecasted. Some users on X speculated on subtler effects, such as increased anxiety or dizziness in humans, attributing it to electromagnetic sensitivity, a controversial topic without strong scientific consensus, but often discussed in wellness communities. Symbolically, the butterfly shape evoked themes of transformation, with posts linking it to cosmic metaphors for personal or global change. Historical and broader context, lessons from past events and solar cycles. Coronal holes have been studied since the 1970s, with Skylab missions providing early X-ray images. A notable example is the Halloween storms of 2003, where multiple coronal holes and CMEs combined for extreme space weather, damaging satellites and causing airline reroutes. In contrast, the 2025 butterfly hole is milder, but exemplifies how even moderate events can heighten awareness during solar maximum. This event occurs amid Solar Cycle 25's ascent, which has already seen heightened activity, including X-class flares and large sunspot groups. Coronal holes contribute to understanding the solar wind's role in the heliosphere, the sun's influence bubble extending beyond Pluto. They also inform models of space weather, crucial for protecting assets like the International Space Station. Moreover, long-term studies link solar activity to subtle Earth climate variations via cosmic ray modulation. This remains debated. For instance, during the Maunder minimum, 1645 to 1715, a period of low solar activity with fewer sunspots and coronal holes, Earth experienced the Little Ice Age, suggesting a correlation but not causation. Monitoring and future prospects. Instruments like SDO, the Solar and Heliospheric Observatory, SOHO, and the Parker Solar Probe are pivotal in tracking coronal holes. SDO's atmospheric imaging assembly provides multi-wavelength views, allowing scientists to model wind streams days in advance. Future missions, such as the European Space Agency's Solar Orbiter, will offer closer, multi-angle observations. As Solar Cycle 25 progresses, more such holes are anticipated, potentially leading to stronger storms. Advances in AI-driven forecasting could mitigate risks, ensuring safer space travel and reliable communications. Conclusion. The butterfly-shaped coronal hole of September 2025 serves as a vivid reminder of the sun's restless nature and its intimate connection to Earth. From its scientific underpinnings in magnetic field dynamics to its potential for dazzling auroras and minor technological hiccups, this event encapsulates the dual allure and caution of space weather. By studying such phenomena, drawing on historical precedents like the 2023 Smiley Face Hole or the 2003 Halloween events, we enhance our preparedness for the sun's caprices. As we gaze at the stars, features like this butterfly not only inspire wonder, but also underscore the need for vigilant monitoring in our increasingly space-dependent world. In the grand cosmic tapestry, this hole is but a fleeting brushstroke, yet it highlights the transformative power of solar science in bridging the heavens and our home.